Welcome to the International Birch University podcast. Today we are diving into the future of artificial intelligence, quantum computing and data with one of the top experts from the tech field. We are thrilled to have Namik Hrle with us, Vice President of Development in IBM's Data and AI Division and Director of IBM's Development Lab in Germany. He's also an international member of the Academy of Arts and Sciences of Bosnia and Herzegovina. He holds the title of IBM Fellow, the highest technical distinction at IBM awarded to individuals demonstrating significant and exceptional leadership, innovation, and business impact. An IBM Master Inventor with 79 patents and a member of the IBM Academy, Namik is globally recognized for his work in data and AI-driven digital transformation and enterprise reinvention. Namik, thanks so much for joining us today. It's a pleasure to have you.
Oh, well, thank you. Thank you very much for the invitation. It's a privilege to share my thoughts on these topics, and thanks to the International Birch University for this opportunity.
Now, your professional background is truly remarkable, and please detail your IBM career, specifically your journey into artificial intelligence and quantum computing. This would help us understand your technical journey a little bit.
Sure. IBM is organized along three major divisions. So there's the infrastructure, there's software, and there's consulting. I'm working in the software division. My role is to define strategy of software products in the area of data and AI. And this is important, with the main focus on software development applicable to large enterprise systems and business applications. So not consumer market, it's a large enterprise system. So my teams develop software components such as databases, artificial intelligence platforms, data integration technologies for clients from the financial, insurance, retail, government, AVO, and other large industrial sectors. So these customers, of course, require the latest technology enhancements in order to offer their mission-critical workloads and to maintain their competitiveness in the market. So this is why AI and quantum computing are in theirs and then consequently in my focus as well.
All right, so IBM seems to be completely B2B focused. Would that be correct to say that it is an absolute business-to-business orientation?
Absolutely, and we'll talk about that a bit later.
Certainly, I'm really interested in learning more about it because we all love IBM and are familiar with IBM's products. So
I'm very glad to hear that. And you mentioned earlier, your experience with some of those. I'm very glad that they are positive. I hope they are positive.
Absolutely. I mean, let's talk about it later on. I'm a big fan of IBM. Let me tell you that. I love IBM's products. Like Watson, SPSS, of course. So I really want to learn more about what's going on right now. But to kick things off, we'll ask you to paint a big picture for us. Namely, artificial intelligence is transforming industries and quantum computing is often described as the next technological revolution. Yeah. For those less familiar, would you please explain what AI and quantum computing are? And how do you see these two technologies reshaping the future? It's an exciting time to live in right now.
Okay. So let's start with AI, okay? Mm-hmm. In general, AI represents a broad field of technologies, such as machine and deep learning. And they are used to develop systems that can perform tasks in ways that resemble human intelligence. Therefore, they can learn, reason, and even create new content. Hence this name, artificial intelligence, okay? Quantum computing, on the other side, is based on quantum mechanics, which is a fundamental theory in physics, explaining how the nature behaves, but very importantly, at atomic and subatomic scale. Not in general, not in like everyday what we see around ourselves, but atomic, subatomic scale. And that behavior is for most people, including also technical people, let's say mildly counterintuitive. It's kind of tough to comprehend, okay? Consequently, explaining quantum computing in few words and without lots of background in knowledge in linear algebra, probability, quantum mechanics is not simple. But I'll try, because most common approach is by drawing a parallel to classic computing, okay? Which is, as we know, it's based on binary bits, which values at any point in time can be 0 or 1. So as opposed to that, the quantum computing is based on so-called qubits that can be both 0 and 1 at the same time. You know, talking.
Well, would you clarify that? What does it mean for qubits to be in the state of 0 and 1 at the same time?
Is because in the subatomic atomic space, the things are actually probabilities, not the states, but the probabilities of all possible states in which a system can exist. And only at the time of reading that system, reading the state, you actually get the state. So this is why you can say that something can be on and off at the same time. This is why you have this, famous Schrödinger cat in a box, which, there's a cat in there. And by the way, it's both dead and alive at the same time. So as I said, it's pretty counterintuitive to think about that, but the whole nature actually works on that principle. Okay, by the way, people shouldn't really feel too bad not to be able to entirely comprehend this notion. I always say to everybody, listen, Einstein couldn't comprehend it. Okay? So Einstein was fighting against it for a long time because, and famously he said, God doesn't play the dice. Because really in the quantum, it's all probability, it's a chance, it's all those kind of things. But eventually, of course, accepted it because that's the fact, how it works. So what I'm trying to say is that this phenomenon is called superposition, and that and other quantum mechanics properties, such as entanglement, allow quantum computers to process a vast number of possibilities all at once and solve some problems for which classical computers would need thousands of years. I always, when I talk to my, my programmer, my IT colleagues in programmers, I would say, how do you program, for example, in a memory, how do you program a little simple game? Let's say you have 4 cards, and then you program a game to pick the queen. One of them is queen and others are something else. How would people program that in a classical computer, right? Well, they will go there and, they have a memory positions of these locations of the cards, virtual cards, right? And depending on what you pick, they go to this position, see what's in there, and come back with the answer, right? So one by one. So what is the probability and how long it will take in average to find the card? It's probably something, a bit bigger than 2, okay? Okay. But in quantum computer, you read all at the same time. It's a single operation. Okay? Because all the states are there, and you just need to read them. Of course, you can always say, but hey, I can actually mimic that with parallelism, right? In a traditional, semiconductor, binary computing, I can basically do this in parallel, reading in parallel, and basically get it in as fast as a single operation, right? Because consumer will see it as a single operation, although there are multiple ones executed in parallel. But I use the example of only 4 cards. How about if you have a 4 billion on a power of billion of cards? How do you do that then? Okay? Classical computers at some point in time stop in their capabilities. They just can't do that. This is, by the way, this is how the encryption, most of the cryptographic algorithms that work today actually work on that principle, right? You know that. I mean, prime numbers, figuring out which prime numbers are making up a given large integer. These are exponential problems that classical computers just simply can't do that. Okay, I mean, it takes thousands or hundreds of thousands of years, okay, to do that, even with the most powerful computers, classical ones. And quantum computer, because of that notion, can do it immediately. But let me tell you something also at the same time. This doesn't mean that quantum computers will just replace classical computers. No, they will not. They will work hand in hand. And as a matter of fact, that's exactly what we are doing right now, finding out how we deliver to the market a complex of systems that are both, traditional semiconductors and quantum computers. Why? Because there is a whole range of problems that classical computers actually solve better than quantum. I read somewhere, and it's not my idea, but I read it somewhere, I can't remember where, so I can't give attribution, but I read somewhere a very nice comparison, analogy, which says, think about classical computers as cars, and think about quantum computers as planes. So to get from A to B, although the planes are much faster, right, than the cars, it's not more efficient to use a plane to take if the distance is small. So if the distance is relatively small, then it's much better to take a car than to take a plane. And this is why you will always have these both working together depending on what the situation is. And now let's just go back to your last piece of the question, which was convergence. What we think about the convergence of AI and quantum, right? Because so far I was only talking about individually what's AI, what's quantum. That's still mostly in the research phase, but there's a well-founded expectation that the convergence of AI and quantum computing is expected to lead to breakthroughs in machine learning algorithms, optimization techniques, computational capabilities in fields like finance, like healthcare, like cybersecurity, climate modeling. So the beneficial impact is bidirectional, by the way. On one hand, AI techniques can be used to optimize quantum computations and improve efficiency of quantum systems, such as enhancing quantum error correction, mitigating challenges like decoherence and so on. And on the other hand, quantum computers can accelerate AI algorithms and make them more energy efficient. Now, IBM is leader in converging of AI and quantum computing. For example, Qiskit, which I would definitely encourage our listeners, particularly listeners in the IT field, to find out what it is and to start playing with that. And because that's available in IBM Cloud, our quantum computers are available, by the way, today for playing with for free. So this Qiskit is software development kit for working with quantum computers, and it's extended for machine learning tasks. By the way, other large players are on the same path. Google works with alpha qubit TensorFlow quantum. NVIDIA just completed their very large conference, and I was just earlier watching a phenomenal video they have created, just absolutely phenomenal about the future of computing. So NVIDIA with their CU quantum and quantum AI framework, or Microsoft with Azure quantum development kit. So lots going on in this place.
So can we say that traditional computers think in one dimension, whereas quantum computers think in several dimensions or in all possible dimensions at the same time, simultaneously? Would that be a correct way of referring to it?
Not a bad analogy. Yes, I could say it is something like that. Of course, there's always some reserves. There are always some kind of,
Yeah.
You know what I mean? When you try to simplify something, then of course that moment you are running into the risk of oversimplifying or something. But I don't think what you just said has merit.
All right. Now you mentioned cryptography and quantum computing. I'm really curious about this, and I think there's a very serious discussion going on at the moment experts are asking, what's going to happen if quantum computing takes over, if it breaks the entire data safety system? What does that mean for the internet? What does that mean for companies? What does that mean for the entire system? Will the system be exposed completely? Would it be rendered vulnerable?
Well, you picked one of the most important cross-industry and kind of beyond even industries challenge that quantum computers are going to pose and pose already today. And that's a so-called post-quantum cryptography that you just said. Namely, quantum algorithms such as Shor's and Grover's, they are capable of decrypting data that is encrypted by currently used cryptography techniques, such as RSA, ECC, AES. The folk that are working in this field don't know what I'm talking about, but there are common used algorithms and techniques for cryptography. For example, Shor's algorithm can efficiently factorize large integers, meaning it can find all the prime numbers, making a given large integer. And as cryptography experts and enthusiasts know, that's actually a foundation of most public key encryption systems. The fact that is very difficult. It's an huge exponential problem to find a prime numbers making up an arbitrary integer. Tremendous problem. It requires hundreds of thousands of years for the largest computers. Okay?
That's just fascinating.
But classical computers obviously can't do that. So this is why all these algorithms have been found, how to do that. And by the way, data is encrypted on a disk, encrypted in memory, encrypted on a wire. I mean, it's all over the place with the same techniques. Now, obviously, this is a major exposure because if we have a quantum computer, if we have a simple Shor's algorithm or Grover's, we can actually break this in a matter of minutes. We can break it in a matter of minutes. Now, of course, the question comes, what you asked and implied. Well, so what are we going to do with this? I mean, this is a major problem, major exposure. Well, because of that, we have already implemented quantum safe or quantum resistant encryption algorithms. And we already, as a matter of fact, in IBM, we already have them in our systems. Okay? So one might ask, why do we already implement quantum safe algorithm if quantum computers are not really easily available? And even if they are available, like in IBM Cloud, they are still very much controlled by us and by our users. So you can't really use them for that purpose. Okay? So why would we then already think about and already implement quantum safe algorithms? Well, the customers from sensitive industries, such as banking or government, and as I mentioned, these are our customers, right? They're actually concerned that rogue players would get a hold of encrypted data today. And they can do that. It's not impossible. You can capture data on the wire. It's encrypted. You can't do anything right now with that, but you can actually capture it. You can break into the systems, you can actually go and read the stuff. It's encrypted, doesn't serve any purpose to you, but you can read it. And if you can read it, then you can get a hold of it. You can download it. You can capture it, right? And then these rogue players are just waiting for broader availability of quantum computers when that decryption will be easily possible, and then just decrypt this extremely sensitive data.
I watched a podcast recently with someone from the U.S. government explaining exactly this point.
It's a real issue. As a matter of fact, I don't want to go into the details, but there are already signs there are some rogue players that do exactly what I was telling you. It
And
just collects enormous number of encrypted data and waiting for that. And this is why IBM has already made post-quantum cryptography available for use in our system. So why? Because the data can be now encrypted in a way that neither quantum computers can break into it.
Well, I think this has to be communicated to the public, to make people feel safer, because, we are growing concerned now. We're really concerned as to where this will go.
Yeah, I agree. But we will come to that, because
fascinating.
I don't think that IBM has enough publicity there. And the reason for that is because it's not in public space. It's not really in consumer space.
Now, let's move to the IBM enterprise systems that you talked about. Now, my understanding is that IBM is a global leader in hybrid cloud data processing and now quantum computing. How is your team integrating quantum technology into enterprise systems, and how might quantum computing change the way businesses handle vast amounts of data? I think that's a really good question
Very good question. Very good question. And that's exactly the question that, that's my day job. But first of all, let's clarify upfront that quantum computing is still in its very early stages. And it's not wrong to say even in its infancy, okay? Many of the early use cases are in the research and experimentation phase. Practical, large-scale implementations are likely still further in the future. Optimistically, I just listened to my CEO the other day, like last week, and he was on some kind of Southwest conference, and he said that he expects that in 3 years. So who am I to say that he's wrong? But I would say, optimistically, it's 3 years. More realistically, I would say 5 years away. Now, it sounds like a lot, but this is not really such a distant future. And quantum computing has potentially industry-changing impact. And that's the reason why large enterprises with which we work invest now in order to create competitive advantage. The most active industries with which we cooperate are financial services, pharmaceuticals, healthcare, logistics, oil, auto industries, particularly, right? Auto industry, because energy and electrical batteries and all those kind of new material, right? And regarding the questions about there is also, so this is basically, these are these areas that we are currently working in industries.
All right. Now, real-time data insights, this is what I wanted to ask you, are already revolutionizing industries like finance and healthcare. How might quantum computing push this further? Are we heading towards a future where businesses make quantum-driven decisions in milliseconds? If so, please provide some examples of this. I mean, the rate of change is just it's unbelievable,
Yes. So the examples I mentioned earlier can be roughly classified as either solving problems that classical computers practically cannot solve, and by the way, theoretically also cannot solve, okay?
Theoretically as well, yeah.
Theoretically is better term, okay? Just theoretically cannot solve. Maybe practically is better because theoretically they can solve in a million years, right? But that's theory, right? I mean, that's not really very useful. So either those kind of problems or accelerating some specific solutions by orders of magnitude. Okay, so the industries you mentioned, finance and healthcare, are the first to actually spring to mind and really the first to engage. So, for example, quantum computing could enable high-frequency trading algorithms to process market data and execute trades in milliseconds. I mean, you know that this is a big thing, and it's been a big thing for a long time. Let me just give you a little parallel. I mean, decades ago, New York Stock Exchange and other large exchanges have created their own networks not to go through the public network, which has typically quite few kind of jumps over different routers and points, and you know what I mean? But basically, they pulled a cable from like hundreds of kilometers long to be in a as straight line to the trading floor from the trader sitting somewhere else as possible, because they actually care about speed of light. You know what I'm saying? Of course.
Absolutely.
So what I'm saying is that if you have a 200, 300 kilometers distance, of course, speed of light is such that makes this distance just kind of laughable, right? But there is difference. There is difference if you go to these 300 kilometers straight line, or if you go these 300 kilometers via 1,000 kilometer jumps all over the place.
Yeah.
And these are microseconds or less. But you know what? That matters.
Absolutely.
And this is why such a millisecond, microsecond, nanosecond advantage on the trading floor is actually important. And this is where the quantum computers can definitely bring a revolution, okay? More leading to more profitable, more efficient trading strategies. Or in healthcare, okay? Quantum computing can analyze patient data in real time to provide personalized treatment recommendation, which of course can improve patients' outcome, right? So it's not waiting for something, waiting for some analysis to happen, but in real time. And constantly, basically, probably with some kind of AI agent added on top of that, it can even act upon that. So this is good. So there are other highly relevant use cases, particularly in the integration with IoT, Internet of Things technologies, edge computing, that will likely benefit a lot from quantum-driven millisecond decision-making.
I mean, this is fascinating. I'm thinking about traders now. Essentially, there's a race going on for acquiring the highest performing system, which to them is a winner. It solves the issue, solves the problem. It sort of gets them in the first place, in the first spot, the top spot. And as you put it, it's sort of, there's a difference between measured in microseconds or less. So only those companies, I presume, that can afford these large systems can actually win in the marketplace. Would that be a correct way of putting it?
Yes, and we will talk about that later also, because I know that you will ask me what I would wish and what I expect and everything else. But we'll talk about that. That's a long story.
Yeah. I mean, yeah, it's really it's really exciting to talk about these things. Now, you mentioned something about the IBM's competitive advantage. So I wanted to ask you, with so many players in the AI and quantum computing race, what is IBM's competitive edge or competitive advantage relative or compared to other companies rolling out AI-based products or similar?
Thanks for that question, because I'm not particularly happy with the state of affairs as of today as far as IBM is concerned. So due to the fact that IBM has been traditionally focusing mostly on large enterprise business, I mean, even in its name, international business machines, okay? IBM is practically not visible in the consumer space, okay? By the way, by design, by intention. That's the focus. We do not do something which we don't really necessarily believe that we even competitive. Others are doing that better, okay? So we do what we do. Well, but that's the kind of negative effect of that is that there's very little coverage of IBM's technology in the news, where there is stories about Google, Microsoft, Amazon, etc. They dominate. So, for example, in the quantum computing coverage recently, there was a lot of publicity about Google Willow quantum chip. Okay? But let me tell you something. I mean, IBM has been at that level of performance already 2 years ago.
I watched the video. I know exactly what you're talking about. Yeah.
It's amazing how much unbelievable publicity, everything else. And this is, and of course, I was asking myself, what the heck, man? I mean, what's the story? But by the way, I'm going to tell you about, I'm not bitching against Google or anything like that. As a matter of fact, I'm absolutely impressed, by the work and everything else. But I'll talk about that in a moment. But that's just one example. Or most recent Microsoft announcement about Majorana. This is the quantum chip, which is based on topological supraconductivity, which sounds great. And I'm just amazed, with the notion of that. But you know what? Nobody can try it. Okay, so we are about to believe. Yeah, well, it's going to be great and all those kind of things, and it's going to be very energy efficient and blah, blah, blah. But, one can't try it. And by the way, quite a few scientists, non-IBM scientists, are pretty much skeptical about its claimed characteristics. Now, the best way to address that skepticism is to give me freaking sorry for this system so that I can see it myself. Okay? But no. Okay. And at the same time, IBM has the largest fleet of quantum computers available to the public already, with the largest number of qubits in the industry, chips, largest number of qubits, available for public use for years. There are already hundreds of thousands of users.
Where can I test one? I'm dying to test one.
Go to IBM Cloud, IBM Quantum Computer, create your user ID and your profile, and you will get a chance. There are different, how they call that, different programs. You will get a program which is free.
What can I use it for? Listeners and viewers will want to know, what can we use it for?
For example, you can use it to test quantum programming. You can have let me see. By the way, we are also going to offer you some ideas. You don't start from it. But if you have some ideas and you believe that, I would be able actually to do this particular problem from the real life using quantum computer, you can use Qiskit, you can use development environment, you can use the libraries, and you can develop programs that will actually run on our quantum computer. And you can see how that actually works. Great, by the way.
Can we use it in the field of biology, finance, marketing, whatever?
Now, mind you, if you get into a scope, if you get into the performance, if you get into the complexity that requires more than let's say 30 qubits or something like that, then we will offer you a program for a small little fee. I mean, of course, that's we also need to eat and
naturally
and so on. We need to earn some money. So of course, for that one is going to be a paid a program. And then at the end, and there are three. I can't remember anymore. I believe there are three different stages: free, kind of advanced, and then professional. And these professional is really used. I know is used by folks like Fraunhofer Institute here in Germany, Max Planck. All these really large organizations that basically do large scale tests and so on. So it is possible to do. But my point is that particularly for our students, even for our Bosnian students, why not? Come on, get on board, get the feeling, get your hands dirty with this quantum stuff.
I can't wait myself. I'll be the first to jump on that.
There you go. And so this is what I'm saying. So similarly regarding AI, by the way, and all the stories. You know how we started. We started with AI long, like decades ago. As a matter of fact, the first signs and very publicized signs of AI within IBM were really with Blue Gene and these Big Blue and so on programs and computers, which are, by the way, supercomputers. Remember, in 1997, I believe it was when we beat Garry Kasparov, right? Um, of course, I remember those days, and I have to tell you, and I always tell everybody, I had mixed feelings at that time because I love Gary uh, for the reason that I hope our listeners understand why I love him. And not only as a brilliant chess player and just genius, right? This is one of those beautiful minds that exist in the world, okay? But also for his I would say decency, his ethics, his integrity, his everything positive. And as you know very well, he's also honorary citizens of our country, Bosnia. So I love Gary. Anyway, Gary lost, unfortunately, to IBM, and that was actually lots of AI in it. Then after that, maybe let's go 10 years after that, we actually won the Jeopardy game, which is even tougher, much tougher, because that requires some kind of cognition. It requires some kind of understanding. Watson beat the champion of a Jeopardy. Well, we never really capitalized nor made big splash about that. And now what's happening, you only hear about OpenAI, you only hear about Microsoft, you only hear about Google, about all those kind of things. And by the way, which is nothing wrong. It should be really greeted with respect and what these other companies are doing, because that's fantastic. It's absolutely phenomenal what large language models actually did. But anyway, what we are doing in AI right now, we are building a smaller, targeted, trusted models. Our model is called Granite, and they are fully open source. Okay? Everything is open source. The weights are open source. How it works is open source. The governance of them is open source. Everything. Okay? And these models can match or outperform similarly sized models from all other leading performers. I know that. We have those benchmarks. But again, I just want to drive this message here. Don't get me wrong, folks. All the enhancements, breakthroughs coming from anywhere, including our direct competitors, are to be greeted with enthusiasm, with respect. Like the latest large language model, DeepSeek from China. It's absolutely phenomenal achievement. It's a great achievement. I'm so excited about that. Frankly, I wish that we in IBM came up with something like that, especially because DeepSeek confirmed what we have been saying all along about preference to smaller targeted models that do not cost, an arm and a leg to develop and run. Anyway, common denominator is everything what I wanted to say is that IBM builds technology for business system that requires highest degree of reliability, availability, performance, security. So when you make a purchase, when you as an end customer, when you make a purchase, when you go to ATM machine, when you make banking transaction, when you interact with insurance or travel agencies, when you go to the retail and pay something, with huge probability, you are using IBM technology, which is underpinning these applications.
Now, while I understand that IBM operates in the B2B segment, I'm a huge fan of IBM's products. Now, what I'm interested in is what's currently being developed and used in the market. What are the hot products that are, being developed right now? I'm waiting to be impressed. Namik.
Please impress me.
Good. Well, how much time do we have? I mean,
as much as you want.
So listen, I'm really, I won't go into much, it's kind of backpacking everything else, or IBM now, IBM. Yeah, right? So I'm very glad, first of all, about the positive experience, and thank you very much for bringing up that flattered. the areas that we are currently working on and see most of the success, and particularly the stock market growth in the last couple of months, despite this latest slump, thanks to reckless economic measures over the pond. Irrespective of all that, it was actually great run on the stock market on IBM. Was basically a success of our AI suite of products. Now, and as I just say again, people do not know that because they do not interact with that directly, but our customers actually use it. Okay, so a suite of Watson, and these are kind of basically a suite of things that are working together in building AI applications. Okay, so you can basically pick up a model that you like, whether this is open source model, whether this is OpenAI, ChatGPT, whatever you like, it is Meta or Facebook, Meta model, Llama, or Google's or Gemini, whatever, right? Yep. You can pick one, and then, but the question is, well, yes, you have it now, but what are you going to do with it? So this whole life cycle of building actually your application using AI, that's basically what this Watson X AI suite provides. Okay. To access data, to create connections to it, but in a governed way, so that you have a lineage, that where the data comes, what is the origin of it, how to use it, are you authorized to use it, is there indemnify issue and risk, is it, lots of kind of stuff that is there, and on top of that, how to store that data to be efficiently consumed by AI algorithms in a data lakes and data warehouses or warehouse lakes, whatever it is, right? So basically, all that suite of technologies we call Watson X. That's been very successful because, of course, our large customers want that because they mean business. They don't want to play and chat. Okay, they want to put AI into their applications so that we do that. So this is a huge area that we are working. Another one is automation. Automation of IT, automation of business processes. We have some organic stuff that we have developed ourselves, but we also have lots of acquisition in this place. We buy a lot of stuff. We, who are old IBM techies, we always look at that with a little bit of a smirch. Why don't you let me develop this kind of stuff? Why don't you buy stuff from others? But of course, it's always a question of time to market. Yeah. So basically, you quickly get to the market, you get that customer base, and then of course you amplify it through IBM sales channels. So of course it works a lot like that. Plus you tap into great talent that you basically buy with this one. And so these are the company like Instana, like Turbonomics, like just the recent one, HashiCorp, a major one, and so on and so on. So that's another area. And the last one, where I actually work very closely and I'm busy, my day to day, we are about to make available in a couple of months' time, a newest large computer for banking customers and insurances and aviation and everything else. It's called Z17. It has the latest chip in it. It's a nanotechnology 5. It is clock chip close to 6 gigahertz. It has specialized AI processors in it, really specialized AI processors in it, and chips that are much better energy consumption than the commonly used NVIDIA GPUs, many times, orders of magnitude. It has a quantum computer integration. We talked about that, basically that the hybrid systems with quantum, and this one is the future. A preview of those. Yeah.
By the way, who came up with that designation? Z17.
Okay. Well, I have to tell you also this one. This one is also funny. Long time ago, maybe even 20, 25 years ago, IBM came up with a special nomenclature for their different system architectures. So we used to actually produce a lot. Maybe your listeners do not know that, but we actually invented PC and all those kind of things. But they decided not to invest into it. But anyway, this is basically what we call X systems. X are basically Intel, AMD, x86 architecture, right? So all these kind of what you usually called open systems and everything else, this is one area that we worked on. The other one is called P systems. And P systems stands for performance. Because on the same wafer chip where we build, we can basically optimize for performance, or we can optimize for reliability. It's always like that, right? I mean, reliable and performance, they clash. Because reliability means using real estate on that chip for redundancy. Redundancy, if one thing goes away, the other one continues working and you don't feel it. But the fact that you've put redundant element on the same wafer, on the same chip, means that you have a less real estate on that chip for performance. Because you can remove redundancy, you can add additional speed up.
Yeah.
Okay. So some of our customers prefer speed up. And this is why we said we are going to deliver them power systems, P. But it's the same, actually, fabric. Same. And then I'm coming, long, like any old guy, I have a long, convoluted way to come to the point. And now comes the Z. Z is actually that same chip that I talk about power, but built with redundancies. Okay? And this is why we have all these measures to make it like that. And we call that chip Z chip. And Z comes from zero downtime. Zero downtime.
There you go.
Unfortunately, we've been here longer than this thing. So we are going to go back to what we had all the time. So now it's called Z. And 17, by the way, is generation. It's very, very long. Of course, these are the systems that have been there for decades. And this is why you have 17.
So Namik, what's your favorite, what's the next tool that you play with on a daily basis, perhaps?
The favorite one is really Watson X Code Assistant, which is for the customer, for our listeners and everybody else, probably they know that this is basically a technology based on AI to help programmers code. So this is like a co-pilot from Microsoft. They will know that much better probably, because Microsoft is 10 times better in marketing this stuff. So co-pilot, and ours is called Watson Code Assistant. And it's basically doing the assistance for coders, for programmers, for building applications. So for coding, creates tremendous productivity in a programmer's work. And also help a lot also in reverse engineering old code. Because we have in IBM is being around for many years. And by the way, this major systems, 360 architecture, later Z architecture, has been around for 40 years, 50 years. So you can imagine there are lots of COBOL and RPG and PL1 and these old languages code, literally billions of lines of code that are, by the way, running the world. But the people who wrote that are Rahmetli mostly.
Deceased for those.
Yeah, that's right. Okay.
Right.
So basically, that means that it's very difficult to make changes. So the code assistant is actually getting in there, scanning the code, refactoring it, creating smaller modules, building a more efficient ones, right? Even if it stays in COBOL, or maybe just transform it into Java. And then suddenly you have a new generation of people, of course, who can basically maintain it, everything else. So that's a really cool tool.
Oh, very interesting. Good to know. Now, so far, we've been warming up, and now we're getting into some heavy stuff. Are you up for it?
Yeah.
Let's go.
All right. Now I've got a question. Noam Chomsky has argued that machines don't truly understand language. They simply predict words based on data patterns. Okay? Could quantum computing push AI beyond this limitation? Is there potential for quantum-powered AI to achieve something closer to human-like understanding?
Okay.
How does that sound?
You start with Professor Chomsky, and then, of course, I immediately, okay, well, I mean, how can I say anything, additional to what he already said? But let me first comment that Professor Chomsky is correct in pointing out the most commonly used techniques for building large language model, which is analyzing the text string, context, and then assigning probabilities to the next word in that string, okay? This technique achieves inexplicably good results. And I'm emphasizing this word inexplicably. It is really not clear to nobody. It is not clear why this approach results in such stunning outcomes, especially when it comes to generating new content. So irrespective of understanding or not understanding, AI generates a novel content as if it possesses a very high degree of understanding. And it's not only understanding, it is reasoning as well. Just a couple of days ago, last week, I believe, or maybe, was it Monday this week? I can't remember. Just a couple of days ago, OpenAI GPT-01 model got a perfect score on Carnegie Mellon math exam, taking less than a minute to solve each of given 10 exercises. So let me tell you, this exam was designed by the people who are in this field know that. It's a famous professor, Paul Shan-Law. He's a professor of mathematics at Carnegie Mellon. He's the US coach of American Math Olympiad team. So these are very challenging exercises, okay? These are not a joke problems. Very, very tough one. By the way, I know that we in Bosnia, our Bosnian girls and boys are phenomenal. They beat Americans, easily. Okay, I know that. But nevertheless, they are not bad either. Okay? So, listen, I would suggest our math students to have a look. You can find it on the internet. Okay, Carnegie Mellon Math Olympiad, you will find that. I would suggest them to look at that and try themselves. I studied mathematics, but I haven't worked in mathematics for a long time, okay? So I went into it, I looked into it, and I got scared. Okay? So of course, most people will be scared who didn't even study, but I studied mathematics, okay? But again, I'm not a mathematician by profession, so of course, it's not so strange that I can't do that. But I gave up. It is very, very tough. It took 1 minute or one. To solve that. All of them, 10 of them, 100%. Okay? So the models such as OpenAI O1 or DeepSeek R1, same thing, they already show remarkable capacity to reason. And not only to have extraordinary language proficiency. So back to concrete question about what additional capabilities quantum computing can bring to AI. I expect to a significant degree, namely, and this is now already philosophical, but hey, you mentioned Chomsky, so
why not? Why not?
we go talk about Chomsky. Well, that gives me permission to be philosophical.
Absolutely, by all means.
So, nature is quantum. I mentioned that earlier. Nature is not binary.
Michio Kaku mentioned that a few years ago, I think. The same thing. Nature is quantum.
So it's really true. Nature is quantum. It's not binary. And with binary bits-based computing, we can only simulate nature, although pretty well, okay? But we can only simulate it. With quantum computers, we will be able to emulate it.
What's the difference between the two?
If you simulate something, you are just making up something which is like that. Okay? It's not exactly that. It's like that. And emulate is basically building a twin. It's a 100%. It's a 100%. It's of course not that, right? Because that is only one, right? But the other one that you are emulating the stuff with is basically the same. I mean, remember Avatar?
Yeah.
So basically, it just takes all the relevant, all 100% characteristics of the original thing. And so this is emulation, right? And quantum can do that. Bits can't do that. Binary, traditional stuff can't do that. So basically, we are just opening some doors that are closed for the time being. Okay?
Right. So you're suggesting that we're getting there, essentially, in terms of human-like understanding, or we're already there?
Definitely, the most conservative way would be to say we are getting there. I mean, we are already seeing really great examples that in some specific areas, to a certain extent, we are already there. But there is really no reason why not continue. That will not continue even further.
All right. Now, Professor Chomsky also spoke about the poverty of the stimulus, emphasizing that children learn language from limited data, whereas AI requires enormous data sets, he said. How does this idea influence your work at IBM? Do you foresee a future where machines learn with human-like efficiency, or the future is already here, from what I understand?
So not surprisingly, again, Professor Chomsky is pointing to a valid concern on this one as well. Because there is something also implicit in his statement. It's not only about amount of data. It is also the energy required for that, because it's proportional, okay? So it is true that the current state-of-the-art models are built with very large amounts of data and consequently cause enormous energy consumption for both model creation and as well as model execution, which is very much unlike the human brain develops and works. So, for example, daily power consumption of ChatGPT is well over 500 megawatts per hour. Okay. On the contrary, human brain works on 20 watts, people. 20 watts. Okay? It's minuscule if you think about amazing results, and in some cases, phenomenal creativity, right? So obviously, there's a huge gap in that respect, and I don't expect it to be closed anytime soon, okay? To close it, right? However, there are many initiatives that try to at least partially address the problem. So, for example, we in IBM developing so-called North Pole. And again, please Google, go check what that is. North Pole is AI inference accelerator chip. Inference, like basically in executing AI model, right? Which implements so-called on-chip memory architecture that is also popularly said to be brain-inspired. In inference tests that we have done just recently, I just talked, a couple of days ago with the chief architect on that one. Dharmendra Modi. And in the inference test that's run on 3 billion parameters large language model, on Granite, our model, North Pole achieved latency below 1 millisecond per token. So this is 50 times faster than the next most energy efficient GPU. And it reached these levels of speed while achieving more than 70 times more energy efficiency than the next lowest latency GPU. So you see, this is the direction where we go. This is still far, far away from human brain efficiency, okay? But it's the direction, and we are making huge leaps, okay, in factors, sometimes order of magnitude. So, as I already mentioned earlier, we believe that the most efficient AI models will be built with limited amount of targeted data, limited, and also using algorithms that do not require massive data sources. They already exist. There are already experiments with that, okay? So yes, we are moving in the right direction. I can't say if AI will ever come close to the human brain efficiency, maybe mine, but not Dr. Chomsky, but there is a huge room for improvement, and it's gradually being addressed.
All right. Now, Geoffrey Hinton, the father of deep learning and a 2025 Nobel Prize laureate, recently raised concerns about AI advancing too rapidly, which is an interesting point, being able to understand and gradually develop consciousness. So that's another huge idea. Do you believe that quantum computing could really accelerate AI to the point, where it starts thinking and where we lose control, essentially? Would that be an option, or could it actually help us build safer and more explainable AI systems? What do you think? This is a huge paradigm shift now.
It is. And again, thank you very much for mentioning, another of my, personal heroes, Geoffrey. So this is another question that needs to start with it depends, okay? Namely, quantum computing could either increase risk or improve safety of explainability of AI systems, and depending on how we approach integration. So, in a bad case scenario, quantum computing, but also other relevant technology enhancements, can lead to creation of highly complex models that are even harder to explain than today, harder to interpret, which, as I said, already in many cases are pretty much inexplicable even today. But what quantum can do, it can bring it like, orders of magnitude of high complexity. Now I'm referring to a true black boxes that are practically impossible to control.
Is that really so? I mean, a lot of people are talking about saying that we really don't know what's going on in the system itself, or in how algorithms work, perform, and so on. But is that possible? I mean, is it a metaphor, or is it really a matter of fact?
No, it's a matter of fact that we have no idea how some of these deep neural networks actually work and why they come with the results as they come. We don't know that. And this is, something that I said earlier. We also don't know how brain works. We don't know how that works.
Well,
Who tells you that it's not the same? I mean, of course, this is now projection, but we don't know either one nor another one. But what I'm trying to say is that these true black boxes, practically impossible to control. Also, speed, that's another one, big problem, challenge, I would say. Speed by which these models are generated can easily become impossible to follow in terms of implementing robust safety measures, ethical guidelines, regulatory frameworks. All this can lead to misuse and unintended outcomes. But I'll come to the punchline. What you wanted to know? What do we can do, right? Because this speed, this black box, actually doesn't allow us to do something that we could actually do. We could introduce these checks and balances. We could. Okay? Whether we are going to do that, it depends of many factors. And this is this bad case scenario. On the other hand, in a good case scenario, quantum computing can help us develop new techniques for interpreting complex AI models it's a different now angle. It can actually help us address the problem that I was talking about. They can make them more transparent, more understandable. So they can also enable better optimization of safety constraints, ethical consideration during modeling. You know what I mean? So it really, it's a two sides of the medal, and it depends of how we are going to behave. So whether we will end up with a bad or good case scenario depends on whether we will aggressively, we human beings, we will aggressively impose human oversight, governance, to ensure that quantum-powered AI systems are developed responsibly, right? And by the way, development of international standards and regulations, such as European Union AI Act, great act, by the way, okay, that can help mitigate risks and ensure that quantum computing benefits AI safety, explainability, and so on. So personally speaking, I'm very much concerned that these systems will be abused, because it doesn't take much imagination to realize that the world in which we are living in is very far away from benevolence, from philanthropy, or even basic considerations for other human beings, as I mentioned in the beginning of our talk. So don't get me started on that again.
All right. Now, in conjunction with that, Geoffrey Hinton has also warned about AI-generated misinformation and the potential for human manipulation, exactly what you said. How does IBM ensure that your systems do not end up being tools in the hands for those who perpetrate misinformation, who disseminate misinformation for various purposes, or for the purpose of social control, for example?
So let me tell you, this one is really, I can tell you firsthand, and it's not bullshit. Okay, I can really tell you firsthand. I've been witness to that from the beginning, IBM has been putting a major emphasis on so-called trusted models. Again, this is driven by IBM's core competence and market segment, large mission-critical clients. So it's not only, I can be a bit cynical, right? It's not only because we have a very high standards of ethical and everything else, which I believe we have, but it's not only because of that. We just have to do that because our customers requires it, okay? So IBM cannot risk that these customers run with unauthorized, non-governed, unsafe data to be a subject of lawsuits, litigations. We can't. We can't afford that, okay? Like many others in the current, outside wild world, whatever is happening, right? We just can't do that. So our models are architected with governance in mind from start. And this is if you ask how you actually do that. How can you do that if you don't know what's going on in there? Well, you can when you start from start, not as an afterthought. You can then provide transparency, you can provide explainability to support increasing regulatory compliance demands. We use exclusively data that is screened and cleansed of any proprietary information. Offensive, biased information, non-authorized use material. We actually tell which data we use for model creation. We are not building models on internet. We are not building models on uncurated stuff. What the data we used that think is very well defined and known, and we vouch, we guarantee for that one that is used on that one. So additionally, what we do, we add hooks into our models so that their decision can be at least attempted to be explained. And
what are the hooks? What are the hooks that you talked about?
Software. Software. When you build a software, you build basically just the checks in it, right?
Okay.
So that you can trace it. A lot of software developers, when they are building their code, they put something in there which is part of that kind of traceability. Okay, so that they know in which state the system now, which variables are now being used. You know what? There are some hooks in the code that help you
identify,
debug, let's say. Usually people use that in debugging when the problem appears. but we use that in our models as well. Okay, so this is how you do it. By the way, I'm not saying that we are the only one doing it. There are lots of open source folks that are very ethical and are doing this kind of stuff. But again, I'll repeat something because it is important for your viewers or readers, listeners to understand. I want to be a bit cynical here. We do not do that only because that's ethically and responsibly the right thing to do. We do that because our customers make it mandatory before they can widely use our tech in their mission-critical applications.
Fair enough. That's a very authentic and, fair statement, I'd say. Oh, thank you for sharing that with me. Now, Namik, you lead teams in Germany and collaborate across IBM's global network, of course. What do you do in your lab, really, and how do you cultivate a culture of innovation with your team when working on frontier technologies, like AI and quantum computing? I've heard that actually you've got a quantum computer in your lab and you're working on it. Would that be correct?
Yes.
Tell us about that.
Yeah.
That's
exciting. It is first on a European soil. It's a very large, over 100 qubits Heron processor, the best. Yes. So how do we do that? Well, firstly, it is important to realize that innovations do not happen in isolation. So by some clever person sitting in the office and thinking of what she or he could think of next, okay? Or at least it doesn't happen often that way. Okay, maybe it sometimes happens, I don't know. But, it doesn't happen often, okay? The innovations are inspired and driven by the need to address concrete, in our case, business requirements that we detect in working with our customers. So, for example, everything I did was inspired by a real life thing that I got inspired when I talked to my customers. Okay? Every single one. They have something, they talk to me, they tell me how they do some things. And I'm thinking, okay, well, could they do that better? This one or that one or something? And I come back and then think about, what I'm trying to say, okay?
Yeah.
So it's always driven by that. And I would also like to give this message to the listeners, if you want to do that, open your eyes, ears, and all other receptors and listen, understand, and critically analyze the situation. Could that be better? Always. Could it be better? Could it be more efficient? Could it be cheaper? Could it be faster? And if yeah, could it be? How? Let me think. But it's a concrete example. You know what I'm saying? It's very important to have this concrete thing. So the innovations are inspired and driven by the need to address these concrete cases. So the ultimate goal is to create technology that will empower our customers to be more productive, efficient, eventually even innovative themselves. So in thinking how to do that, innovations and inventions are born. And then it is very important to have conditions and support by the company you work for. Innovative work needs to be encouraged and rewarded. As a matter of fact, innovation needs to be an integral part of one's organization culture, of its identity. And by pursuing these goals, IBM achieved to be almost for 30 years back, by far the largest generators of patents in industry. Not by chance, because of that culture of innovation, encouragement, reward, and so on.
And who does IBM sell that to? Does it sell it to the industry leaders or to other companies, competitors? How does it work?
Yes. First of all, most of our patents, most of them are really used to protect us against others. Okay? Because in the large corporate world, it is very easily to be sued for using an idea or approach that somebody patented. Okay? So what we do when we come up with some idea that we want, we patent that so that we are protected from others to sue us. Okay? That's a big part of this story. Okay? The second part, and by the way, most of my patents belong to that category. And most of my colleagues' patents belong to that category. And then there is, of course, a category of patents that are basically have a business value. Okay, we are talking now about this kind of benefits of patents and in terms of financial and so on aspects. But you know what, Engin, the most important thing is to create the culture in which people, this enormous collective mind, actually start working and thinking and innovating and everything else. And that's very healthy atmosphere.
How do you do that, Namik? How do you create that a collective mind, as you put it? What do you have to do to get there?
Concretely, for example, we have an institution which is called Master Inventor, and I've been Master Inventor for many, many years. Master Inventor means this is somebody who is a coach. He's somebody, we have even a little stickers in front of the office, which says Master Inventor. And that means that anybody can come at any point in time to pitch something to you.
Oh, cool.
Okay? And you serve as a sounding board or a guide or coach or something like that, and particularly help with the process of how to go through that. Because as you know, it's not exactly easy process. It requires certain steps to be done, legally, lawyers, all those kind of things, right? And how to write a patent in the right way, how to write innovation so it can be actually evaluated appropriately by the boards. That language is, by the way, a bit strange. If people see some of the patents, they can say, what's this all about? But, it's required to be in such a format and so normalized so that you basically can compare. And the systems, also expert system, can compare patents and everything else. So anyway, this is one way how we do that. Another one is that very often I organize, for example, patent mining sessions. Okay? So basically, once we, start, let's say, with the next project, we come together, whole group, and then start mining. Okay, we know what this project needs to do. And then we say, okay, how can we store this data most efficiently here? How can we access it here? How can we make these two data coherent in the most efficient way and most transparent? And then people start mining, thinking everything else, and so that's it. So you have to have some how would I say, some mechanism, some environment, healthy, fertile environment for that.
Absolutely. Years ago, Professor Michio Kaku published a very popular book titled Visions. Now, Namik, I'd love to learn more about your visions of the future. How do you envisage our future? Why? We know that quantum computing is often seen as futuristic. And, how close are we to seeing practical applications of quantum computing, let's say in the commercial sense, and which industries do you think will be transformed first by quantum breakthroughs in the near future?
Okay, so as I mentioned earlier, we expect that practical large-scale implementations of quantum computing will be seen relatively soon, say in 3 to 5 years. And I'm talking about large-scale implementations. Okay, some of them already exist, but large-scale, big time, this is then 3 to 5 years. And the industry that would lead exploitation of quantum computing are financial services, where quantum computing will be used for portfolio optimization, risk analysis, fraud detection, and, for example, quantum-resistant encryption, which we already covered, right?
Yeah.
Then pharmaceuticals, healthcare, for drug discovery, and for personalized medicine. Then there's also a major potential in optimizing supply chain management and logistics, okay? And of course, we expect that quantum computing will enable breakthroughs in material science, For example, benefiting electrical batteries development. Okay? And to sum up, whenever very intensive, complex problems that are exponential in nature, meaning every new parameter makes the solution exponentially harder to solve. These problems are the target for quantum computing. So that will be also a hint for your listeners who want to get into this one. If you have that kind of problem, exponential in nature, that's quantum.
What role will IBM play in shaping that future? I think that's a very good question for IBM here. Where do you see IBM and, or what role actually, and how does IBM figure in that future?
Right. So, just to create a background for and hone into to concrete answer. AI has the potential to further accelerate digital transformation. And IBM is all about that, okay? And digital transformation, as you know very well, this is basically enabling new business models or fundamentally change the existing ones. So think about what impact internet had on almost everything. It changed the way we communicate. It changed the way we shop. It changed the way we consume news, entertainment.
Do business.
So think about smartphones, which, in my opinion, the best examples of so-called killer apps that are enabled by internet. Okay, well, I feel AI has the potential to change the way we live, like internet did. By the way, despite some great achievements, AI still is in its infancy. And I like to argue that there is still not a killer app for AI. When you compare with killer apps for internet, such as iPhone, streaming services, online shops, etc. But internet also needed 10 years from when the industry started adopting, like a late 90s. iPhone came up in 2007, 10 years, okay? So it's needed that time until these fundamentally new businesses and services appeared. So I don't think it will take 10 years from AI to get there. And now regarding IBM role in all this, I see it really in championing and developing truly open, trusted, safe, secure, energy efficient AI. I already mentioned that's not only the right thing to do from the aspects of ethics and sustainability, that also provides optimal value for our customer segment.
Does the IBM cooperate with universities? Are there any programs and things of that nature?
Cooperate with lots of universities, of course, in each of the countries in which we work. So, for example, I work in IBM Germany, and we actually have a very close relations to lots of universities in Germany, particularly in the area where I am, which is southern, West Germany. So university like Karlsruhe, Institute of Technology, or Freiburg, or Stuttgart-Vaihingen, we work very close to them. But also with TÜM, Technische Universität München, and Bamberg, and all of them. Yes, we do actually very closely with them. Also, we have these programs with internship, where we bring the, people to work, and we have a program called Masters at IBM. Which is basically the program designed for students that are on their master's degree, and they work 50 or 70%, not full time, part time within IBM, and we pay them for that, and so on. So yes, they're pretty strong kind of relations.
All right. Now, formulating the right questions. This is what I wanted to ask you, Namik. So formulating the right questions is often the hardest part, isn't it? Now, based on your experience, what are the most relevant and thought-provoking questions we should be asking now about the future of AI and quantum computing? This serves as an introduction to the following question, which I'm eager to ask.
For this question, because I really want to get this out, okay? It appears to me that the most relevant question is the same that apply to most technological advancements in history. And here I'm referring to the advancements and innovations that have a major impact to the way we live. And that question is, what needs to be done to ensure that the economic values and quality of life is not limited to only few and leave out majority of the world? How can we achieve that there is no monopoly on technology success, although most of the advancements in the contemporary age is generated in selected geographies, such as what we call West, right? By the way, dominated by the US, and selected East, China. So irrespective of the geography, what can be done to ensure as painless transition to the new way of manufacturing and service providing? And listen to this is very important. Meaning how to compensate for inevitable loss of jobs and retrain affected population for new conditions, new requirements. By the way, this is not new. We lived through this. Every industrial revolution brought this, right? I was part of that. I saw that in the digitization of the back office when I started my work, back in the 80s. I saw a literally army of people losing job because, of course, not overnight, but gradually, because back office was digitized. So there is no need anymore for administrators and we call them referents, right? Material management, like a payroll, sales distribution, all these kind of things. That was basically computerized, and we just lost these people. Well, these people had to somehow find another job. AI, quantum, and all these technological advancements are not different. So we have to really work on finding out how do we do this transition, because transition is inevitable. Okay, we are not ludists, right? We are not going to basically destroy machines, right? Remember Ned Ludd. We are not going to do that because it's impossible. But at least we can put our intellect and everything we have. We can put even AI maybe to find out how do we do this transition. So it can be as painless. It's not going to be painless, but as painless as possible. So for me, these are the key questions. How to make sure that there is no monopoly on this one, on these technologies. And secondly, how do we make sure that we do the transition? There are many others. We already covered them, enforcing ethical use, fairness, avoiding bias, achieving efficient use of computing resources, associated power consumption. And we can also add a desire, which seems utopian at the current state of world affairs, a desire not to end up in abusing technology for military, aggressive, oppressive purposes, exploitation of others, which, by the way, happening as we speak.
What do you think we'll see in 5, 10, 20, 50, even 100 years from now? How do you envisage that future? It's a tough one, I know, but it's an exciting one. Yeah.
I try to keep it as short as possible. So, first of all, the IT technology is developing so fast that predicting anything, even just a few years ahead, is very unreliable, very unrewarding. I often use a quote that says, "It is difficult to make predictions, especially about the future." I realize that this sounds like one of Grumpf saying. Grumpf. I don't know if you know about that. Some of the listeners might be familiar with that colorful figure from Alan Ford, Pulp Fiction. This is when I was young. Maybe this is a joke that not everybody will understand. But anyway, but actually, it's also attributed to many other celebrities, right? Including one and only Niels Bohr. So There you go. Good company to be in if you use that one. So let me formulate the answer as what would be my wishes in this respect. I wish, and by the way, when I say I wish, I also believe it is possible. It's not impossible. That's actually absolutely feasible, okay? That AI and quantum computing, but also advancements in traditional semiconductor technology, don't forget that one, that's still continuing, okay? And especially in convergence of these three, okay? That creates conditions to address some of the toughest challenges, such as finding therapies for, until today, incurable disease. That's absolutely possible, okay? Or improve sustainable food production, irrespective of geography. Personalized, when I say personalized, I mean customized for that region, most efficient, but sustainable and not damaging for environment. These are tremendous problems, okay? These are so difficult problems to solve. But AI, quantum, semiconductor enhancements, and the new stuff that is coming up, whatever it is, can help us actually solve these absolutely crucial things, okay? So it can also improve, some people call it, demography of one. Demography of one is actually just the ultimate extreme personalization. And when I talk about that, I'm thinking about personalization in medical care, but also how about personalization in education? Extreme personalization education. Basically, you create a single specialized educational program for a single person, each different, okay? That fits that person's sensibility, nature, behavior, capacity. You know what I mean? It's
absolutely, absolutely.
So these kind of hard problems, I believe this is what it can. And I'm convinced this is not science fiction, okay? At least from the technology feasibility perspective. And I can only hope that these use cases will be prioritized over some other much more sinister ones.
Yeah. Fair enough. Before we close, Namik, there's a question that I'd like. It's an interesting one. Actually, we asked an AI system to analyze your work, okay, and pose the most probing question it could generate for you. Okay, here it is. When quantum computing transcends classical limits and fuses with AI at scale, potentially enabling real-time simulation and optimization of entire systems like global economies, biological networks, or even human cognition, will this convergence expose the final architecture of intelligence itself, or will it reveal what we call intelligence is merely an emergent transient process with quantum reality holding deeper forms of computational existence that neither humans nor classical machines could ever conceive?
And again, I have to tell you, when you sent me this question, I could only assume, this is either a question that you asked, Professor Chomsky to come up with, or as a deep seek came up with this one. But anyway, good question, really good question. Let me.
I'm not going to say which one it was.
Okay, I'll answer the later. So let me elaborate.
It's the other guy.
The other guy, yeah.
All deep sea.
The second one. No, let me elaborate on this one. So as I mentioned earlier, okay, we have no idea why a relatively simple large language model algorithm of determining the most likely next word from a given text results in really astonishing outcomes. And it works so well for so many use cases. So we also know very little about how exactly human brain learns, reasons, creates, imagines. And despite some seemingly big advances in our understanding of the world and cosmos, we are still only scratching the surface. Okay, this is personal, but you ask me. I personally firmly believe in God's message. Okay? And God's message is that the ocean of knowledge is infinite, and that we should constantly learn and work on peeling off the next layer of discovery in that immeasurable, endless pool of knowledge. So I see AI, quantum mechanics, and computing, and many other scientific disciplines as helping tools to make the discovery of that new knowledge possible. Okay? So these technologies can complement, augment human intellectual capabilities in a similar way, but I would say much more sophisticated, as the mechanical machines augmented human physical capacities in the industrial era, right? So I'm intentionally using this term augment to make a point that A in AI doesn't necessarily need to mean artificial, but can also mean augmented as well, right? So AI as in augmented intelligence to support the concept of human and machine rather than controversial machine instead of human.
Mm-hmm. Well, that's a very interesting take, Namik. We could discuss that for I guess many hours, and it's a very profound actually synthesis that you made and opened up a whole new area of research and human reflection, I guess. Now, you've had an inspiring journey from Bosnia and Herzegovina to a leading role at IBM, working on some of the most advanced technologies in the world. What advice would you give to students in Bosnia and Herzegovina who dream of making their mark in AI, data, or quantum computing? What's the message for them?
Okay, let me recall the previous answer. In one word, ikre. Learn, read, use every opportunity to learn the new technologies, and AI and quantum computing definitely qualify for paying lots of attention to. The half-life of expertise in IT has always been pretty short, okay? So even when I started, the knowledge got stale quickly. I intentionally say half-life of expertise because it's more accurate than to say, some people say, expertise expires, it's not valid and so on. That's not really true. Because in reality, everything you learn, actually the process of learning itself, which I believe is the most important, is actually more important than learning itself, just process of learning. It's highly valuable, and it builds up one's value, employability, competitiveness, career, whatever. Only in IT, more than elsewhere, currently, by the way, but maybe not be always like that, but currently in IT, you cannot lose the pace because the tech is coming up all the time with great speed, and to stay at your best, you need to keep up. So you do that by constant learning. A good thing, much better than when I started, is that the knowledge it's much more readily available. Thanks to the internet, an enormous amount of information available online. So keep yourself up to speed with technology and do not be afraid to get out of your comfort zone. Not all the time, but when it's needed, when you feel it's worth it.
Namik, thank you so much for this highly informative and inspiring conversation. I believe it's been incredibly valuable for both students and the general public, and I can't wait personally to have another one with you to continue this conversation and move into AI and quantum computing at a deeper level.
And thank you very much for the invitation and very relevant and inspiring questions.
Thank you so much. Really look forward to having you on again. Thank you, Namik.